All right, last installment of naming, and this is acids. One of the most important features of acids is that they are hydrogen containing. So everything that's based on an acid is got H+. It's just a matter of how much H+ do they have. And that'll really give us a handle on the charge of their partner, because their charge is just going to cross like it has been for many of the compounds before us. Oftentimes you'll see this little AQ. This just means that it's mixed with water, and that's because it's a homogeneous solution. That was a synonym for homogeneous back in our first chapter. So really when it comes to acids, it's back to those same basics of, does it have two binary kinds of elements in the acid, or does it have three or more? And that would be the ternary and beyond kinds of compounds. So we too can break these down into, are they oxygen-based acids with ternary, ending in those 8s and ites, or are they just binary, ending in those IDEs? So let's kind of look at those acids from that kind of approach. First ones we're going to look at is binary. So again, when you're binary, in this case, it's a little bit easier than binary ionic, because if you're binary, you have two, but if you're an acid, one of those two is H+, and it has a +1 charge. These acids come from things that would end in IDE because, again, they're binary. And what we add here is a prefix hydro, a suffix ic, and then we throw acid at the end. So in the case of HF, we would say hydrogen fluoride. So because it ends in IDE, that tells us it was binary, but now we add hydro in front of fluorine, and then instead of ide, we say ic acid. A fun way to remember this is to remember the sentence, my ride has hydraulics, because you can see that binary IDEs end up with hydro-ic as a substitution for its name. So all of these have fluoride, chloride, sulfide, and they all become hydrochloric, hydrosulfuric, all in that same kind of sequence. So if you see hydro and you see ic acid, you know it has to be binary, and it has to have one of these simpler kinds of formulas in order to be the answer. That's different from ternary. If we have ternary acids, it's because now we have T4-3 based ions. So we're going to expect to see the 8 versus ite endings. So now it's all about the oxygens. Just remember that if you're looking at oxygens, 8 is always up. 8 is always up. So always look for that higher number of oxygens to be an 8, those lower number of oxygens to be an ite, and that's still a huge clue on how to name these compounds. In these compounds, 8 becomes ic, and ite becomes os, and that's really the only pattern to show you. A fun way to remember it would be, I ate something icky. So eating something icky, acids are pretty icky in themselves, very sour in taste. And then if you think Sprite is delicious, you can recognize that similarity of 8s give you ics and ites give you os. It's all about being higher in oxygens. So higher in charge was ic versus os for transition metals. Now ic is higher in oxygens, os is lower in oxygens, and that 8 versus ite is the determination for that. So T4-3 is really your best friend. The alternative to T4-3 is lots of flashcards, and now even more flashcards concerning acids, which would be painful otherwise. So take some time, practice T4-3, use T4-3, and you can really educate a lot of your guesses towards right answers rather than wrong answers. For the halogen sequence, it's a little bit bigger because you can go a little bit further than T4-3, and you can go a little bit less than the ite of T4-3. So T4-3 is still here. We'd expect chlorine being in the 3 box to have 3, and that's what we see here. But notice we can go even higher than 8 and become per 8, and we saw that with the polyatomic ion list briefly. You can also lose oxygens and become ite. We expect that from just about every example of our polyatomics can do that. But now we can see that we can even trickle down even further and become a hypoite. So the clue here is you still got to recognize T43. If you recognize T43, you're going to recognize the ic acid. If it has more oxygens, it's still an ic acid, but you add per, just like the perchlorate ion. And if you have fewer, it's going to go to an ose. That's because you came from an ite. But if you lose even more from an ite, from what you would predict, that's when we add the hypo, but still an ose. So 8 is still up. Oxygens are still up. It's just that when you're at the highest oxygen content possible, we add per, just like peroxide has an extra oxygen, so to speak. If we're at the lowest amount of oxygens possible, which is in this case only one left, we get this hypo prefix. So use T43 and then either go up for extra oxygens compared to T43 or go down either once or twice to deal with less oxygens for T43. So in summary for acids, what we're really looking for is binary versus ternary in most cases. Does your acid have hydrogen? The answer is always yes. Notice all of these have hydrogens. The big thing with acids is they have H+. That's a given. That's not what most of your homework and eventually things that are going to be on the exam are going to cover. What they want is, what about the acid's partner? If you're binary, if you end in IDE, my ride has hydraulic acids is the key. If you're T43 based, you have to be careful. If you're T43 based, you're going to have T43 ions ending in 8. If you ate something icky, 8 gives you ic acids, and that's exactly what we see here for sulfate becomes sulfuric, nitrate becomes nitric acid. If you lose oxygens, sulfate becomes sulfite with SO3. Sprite is delicious tells us that I gives us ose acid, so sulfite gives us sulfurous acid, so sulfurous acid, and then nitrate became nitrite, losing an oxygen. Nitrite becomes nitrose acid because, again, it's Sprite is delicious. Nitrite is delicious in this case. So nitrous is the answer. So it's really paying attention to that pattern, T43, what it can tell us, and then looking for binary. It's all with the endings of the word. We talked about how we could recognize compounds as early as week 1, and now we're recognizing those compounds specifically for their acid type names. So here's 3 examples. So when I look at 3 examples like this, I notice that, again, all 3 have hydrogens. They're going to be acids, and that's given based on the slide. But if this were just a random question in the homework, the fact that they have hydrogens and no metals tells me that they're acids. And then I see bromine. So what are some clues to take away from this example here? Well, in this case, H and Br, that's just 2. 2 is binary, and that gives us a huge clue. Binary tend to end in IDE. Down here, for B and C, right, we have 3, and that's ternary. So in ternary, we have to worry about, is it the ATEs or the ITEs? And the only way to know is to realize that the ATEs are always T43, and they're always a higher number of oxygens. So of the 2, the 8 is more likely to be an ATE, the 3, the HBr3 and letter C. This 3, the fact that it has a higher number than the 2 tells you that this is probably the ATE. The only way to know for sure is to look at the periodic table. So let's pull that up real quick and see if we can recognize the difference. So again, if we had a periodic table on the exam, this is one of the first things that I would want you to do to it. I want you to look over in that corner and then think T43 and then see what it can tell you. So when you think T43, think here's T, right? And then here's 4. And then here's 3. So all of these are going to be like BO3, and all of these are going to be like PO4, right? But for the example that we just did, notice here's bromine. Bromine's going to be in the O3 category. That's all we need to know. Because if it's in the O3 category, that is the ATE. And that's what we want. So recognizing that bromine's in this kind of 3 box here in the end tells us that it has 3 oxygens, and that tells us it's 8. So that's going to tell us as an acid, it's going to be an ick acid. I ate something icky. So using that pattern, learning that pattern, definitely to your benefit. Otherwise, it's lots of flashcards. So if this one was the one that was ending in IDE, this would have been hydrogen bromide. So because it's IDE, we would say hydrobromic acid. My ride has hydraulics is the idea. Once we recognize that 3 was ATE, that was based on the T43 pattern. Now we know that I ate something icky, this would be bromic acid. And by knowing that 3 is more than 2, dropping down, that's just ITE, Sprite is delicious, tells us that this was just bromous acid. So hopefully using those patterns, we can better see, or predict anyway, some educated guesses on some of these homework questions, and not have to rely so heavily on flashcards. And lots of naming, but now it's over. Catch you next time.